So yeah, going to give you a quick run through of GPS technology and what it can do for you, hopefully. So firstly, to introduce myself, as Dana said, I'm Andrew Williams, and I'm the service manager for Vantage England and Wales. So I've got a family farming background, grew up on a farm, so I've always had an interest in farming and machinery. I spent several years operating and driving tractors and machinery around the Welsh countryside. Before roughly 10 years ago, I got into the machinery industry. I spent the first portion of that working for a manufacturer, and quite a bit of that time was spent abroad traveling and helping people to get the most out of their machines. And then for the last 6 years, I've been working with GPS technology. So I can share some of that with you tonight. So who are we? Who do I work for? So I work for, as I said, Vantage England and Wales. Vantage was created out of AS Communications. You may have heard of AS Communications. Henry's been flying that flag for us for several years now. And primarily we are Trimble GPS authorised dealers. So we've been Trimble dealers now for over 20 years. So we were actually one of the first Trimble dealers in Europe. And so yeah, that comes with it. We've got a lot of experience in that sector. So we've got 6 field-based sales staff, 5 dedicated service staff, as well as 4 specialised sub-dealers. So we've got good coverage across all of England and Wales. And that leads us into Henry. So Henry is our man in Wales, so to speak, or South Wales at least. He does a really good job for us of covering South Wales. And he's been working along with the founder of the company for over 12 years. So he's got a lot of GPS experience. And as Delana said, as well as that, he's a farmer and a contractor. So unfortunately, he can't be with us tonight because I spoke to him earlier and he's busy bailing. At least we know where his priorities are. So what do we do as a company? So primarily we are the aftermarket dealers for Trimble agricultural GPS equipment across England and Wales. So aftermarket is the key there. So we don't actually get involved with the factory fit equipment very much. We can provide some services for it in terms of correction signals and some service work on it, but primarily we deal with aftermarket. So we are fitting and servicing equipment to tractors that have nothing on already. That can be brand new tractors, or it can be some older equipment. We'll see a little bit later. So yeah, we specialise in the sales, installation and service support of that equipment. We're also a Trimble repair centre for the UK. So Trimble have granted us permission to do warranty work on their behalf. So we can actually, you can see from the picture, we can actually strip units down and do complicated work, you know, an update and necessary and on behalf of Trimble as per their warranty scheme. And as I said earlier, with the 20 years of the dealership that comes with then a lot of industry support and expertise. So we're really proud of the fact that we've been in this industry a long time. And then going forwards, more and more important is the software and data interpretation side of things. So I'll speak a little bit about that later, but I'm sure we all know there's more and more data coming into the world, and we're having to deal with it daily. So software and farm management stuff, that's going to become more and more important. So it's just going to hopefully nip into a quick video that'll just give you an idea of some of the things we're involved with. So that was just a quick snapshot of a couple of things that, a couple of the machines that we're working on. Hopefully we'll come on to a few of that after on. So what is GPS? We talk a lot about GPS and GPS technology. What is it? Essentially, it's sat nav, or we're all using it regularly in vehicles. I'm sure in tractors and in cars, in our mobile phones. And GPS for me is a world of acronyms. There's loads of acronyms: VRS, RTK, GPS, GLONASS. Loads of them. And to be honest, you don't really need to know about many of them, if any of them. That's my job to worry about those. Particularly the GLONASS, the Russian one. I'm not going to even attempt to say what that is. But very simply, GPS is the United States segment of a wider GNSS network. It's a network of satellites put together to make up a global positioning system, or global navigation satellite system. So GPS, the American part, that builds the basis of all satellite precision farming systems that we use, that everybody uses for location, geolocation, regardless of age, make or model. So no manufacturers have got their own satellites, despite what they might tell you. And all the other ones, so GLONASS, Baidu, and all this sort of stuff, they're only additional systems added to augment the basic GPS. The GPS was developed by the US Department of Defense during the Cold War. And the first system was in operation in 1964, so it's not a new thing, it's been around a while. And GPS consists of around 28 satellites, 24 of those are in constant use, and then 4 are spare. But GNSS in total, so all of the satellites used for positioning, there's well over 100 of those now. So all these additional satellites that are coming on more and more all the time, that helps us to get more and more reliable positions, better positioning data. So the GPS satellites particularly, they're positioned at around 21 kilometers above the Earth's surface, and they circulate the Earth roughly twice every 24 hours. So every satellite passes over us each roughly twice every 24 hours. And they cost about $250 million to put into space. So they're quite expensive pieces of kit, and they weigh just over 2 tons, and they've got a design life of 15 years. So they're continuously being replaced and evolving. So that's the techie bit out of the way, just to give you a bit of a background of what we're dealing with. So more importantly, what can GPS do for you, for us as farmers? Very, very simply, all GPS is doing, it's telling us where we are. You are here. There's a lot we can do when we know exactly where we are. It's really important. So for us as a company and what we do, the main things, the main advantages or the main uses for us of knowing where we are is guidance, tractor, machine guidance, telling us where to go, basically, be that manual guidance or fully automated guidance. We'll come on to that in a second. The other portion, application control. Some of you may have had a chance to listen to the other webinar where Ben was kindly speaking about application control and what these guys are doing with that, or the benefits of that. And we'll speak about that shortly. And then the final one is mapping and data management. As I said earlier, that's going to become more and more important going forward. Having the ability to map our farms, to know what we've got, and then manage the data that we're gaining from using all this equipment. So to start with guidance, manual or automated, why would we do it? What is it? Why are we doing it? Simply put, would you prefer the left hand or the right hand? If I was driving the forager, I would pretty much guaranteed prefer to be driving the right-hand swath. Make my life a lot easier if I just have to follow that nice straight swath all the way to the end, rather than the wiggly ones on the left-hand side. So how do we actually do that? Like I said, there's range of things we can do, from the very basic, but still very practical, Easy Guide 250 there in the bottom left-hand corner. There's a lot of them running around now, and it's still a current unit. We still sell several of those. Still great technology, very simple, very easy to use, and does the job. And then moving on, we've got the GFX 350 now, which is the next generation of smaller, simpler systems. What's good about the 350 is that it's fully expandable, so we can add to it to do more and more things, like the application control and the isobus, which we'll speak about later. So how are we actually steering the tractors? So either manually with the light bar, so we're using the lights on the display, or the coverage, the painting on the screen that you can see there in the top left, the coverage that then essentially is telling us where to go. We use that as a guide. Or we can retrofit a system to steer the tractor. So photos in the middle, we do a very basic, what we call the easy steer, again, still available. It's very unintrusive in terms of fit into the tractor, and can be fitted to most makes and models. The easy pilot on the right-hand side, so that, as Delana led us into, that's a tractor on my family farm at home. So my grandfather's, now my father's tractor. And so that's a 35-year-old tractor, and we fitted GPS to it. You know, surprisingly practical, really handy when you're spreading fertilizer, rolling. There's lots of benefits to it. We'll come on to those in a minute. So we can do everything from really old equipment like that right up to the modern, the brand new fast track there. So that can come out of the factory, what we call guidance ready, and then we can just finish that with a GPS receiver and a screen in the cab, which allows you to do to steer the tractor basically. So there's lots of different ways of doing it, and we're pretty confident we can have a go at most things basically. So why would you do it? What are the benefits for using GPS guidance? The really outstanding and simple benefit would be reduction in overlaps and misses, leading to greater efficiency. You know, nobody wants to go over the same ground twice. I'm sure we've all been doing it when we've spreading fertilizer or something into a freshly cut field of silage. You can hardly see where you've been. So, you know, having some sort of guidance, even if it's just manual guidance at that stage, to know where you are, where you've been, is really useful. The other thing in terms of greater efficiency is the ability to not necessarily work from one side of the field to the other. So to work in lands, so to speak, but those lands to be perfectly parallel to each other, so that we're not overlapping. That you can't underestimate how much that helps in the efficiency. For example, it's a little bit hard to see, but the mower, the Big M, Chrome Big M mower, that's a factory available system, and that means he can do every other pass up across the field and then come back and then fill in the gaps, and he knows he's not going to be overlapping, or he's not going to have any skips or anything like that. And that allows him to turn nice and quickly on the ends without having to turn too tight and make any damage to the field. That's really valuable. And then we also can't underestimate the aesthetics. We all like to see some nice straight lines in the field. It's for me anyway. It's a really important part of having it, just to make sure you can get those lines nice and straight. And then again, particularly when we're putting our inputs down, things like fertilizer or chemicals, we don't want to be overlapping or wasting those. So there's a lot of you know, to make sure we're not overlapping and putting any more on than we need to. And that can not only financially, but that can have quite a big effect on the crop, because if we're overlapping with the fertilizer, we've all seen fields of stripy fertilizer or too much fertilizer, and it's not nice to look at. We don't want to say we've done it. I'll be honest, I've done it. But that can have an effect later on. You know, that grass then is growing faster than the rest of it. It's growing heavier, so it's going to be mature earlier. The field isn't even, and that can cause you problems later on. So, you know, it's surprising how a simple manual guidance system can save you a lot of stress later on. Then the other big side of it we haven't touched on is the ease of operation. So Delana actually gave me an example before we come on the call here about somebody she knew that had allowed an older gentleman to stay drilling and driving the tractor because he could do longer days, and it makes his life easier. He's not focusing on that marker all the time. And I hear time and time again, everybody thinks they're buying the GPS because they're going to save money on inputs, but actually it's the reduced fatigue and the ease of operation that generally people like the most about it. They can put long days in, they get out of the tractor or the machine at the end of the day, and they're not exhausted. That means that the work you're doing is better quality, but also you have a better quality of life as well. So we're really proud, as I said earlier, of the fact that we can steer almost anything. You know, we really there's not many vehicles we've given up with or not been able to do at all. some quite famous vehicles, big vehicles, small vehicles, odd things we can really have a go at today. So just as a couple of examples, the bottom picture on the bottom here, that's a pea harvester over in Lincolnshire somewhere. This is a spinach harvester up in Shropshire. This is planting lettuces over in Norfolk, I think. It's Big M, obviously mowing grass down in West Wales. You know, we're all over the country and doing some really interesting, weird, and wonderful vehicles. So there's automated guidance. That's as we've just been speaking. That's a big part of what we do, and it's more than just going in straight lines up and down the field. We're getting more and more advanced now with the system. So I'm going to show a video shortly, but this system can actually steer the operator down the field. So you'll see that he's missing one pass. He's not going up and back. He's missing, and he'll fill in the gaps later. But not only is it steering him down the field, but it's also turning him at the headlands. So we'll just watch this video now. So you can see he's having absolutely no input at all on the steering of the tractor. So it's a retrofit steering wheel, electrically steering the tractor. So all he does is lift the implement up when he gets to the end. It's turning. He's got faith in it. And then he returns the machine back to work. And away to go again. And he knows now that he's got exactly the right gap left so that he can fill it in later. And this it's an interesting example, actually. This is a contractor mowing grass, obviously, but he also uses this tractor, the same tractor, then to rake the grass and to bale the grass. So he does all the operations using GPS. So he mows it, rakes it, and bales it, all with GPS using the same lines. Interestingly, actually the first in the UK, we often can be confused in thinking that this is for big arable farmers in the east of England. And yes, it does. You know, it's very useful over there, and they get a lot of use out of it. But there's a lot of the pictures and stuff you'll see are used here in Wales. So actually, I did the very first test of this automated headland turning system down in West Wales. And it's surprising how useful it is when you're spreading fertilizer, for example. Again, when you can't see where you've been or where you need to go, whereas previously you would turn in and you know, hope you're somewhere near and then use the light bar, but you'd have to do a bit of a wiggle to get yourself right with the light bar. With the automated system, it turns in perfectly, and you just know that it makes the nice smooth turn and then straight into work. There's no wiggle at the end or anything like that. So moving on from, or just before we move on from, so we're doing systems for guidance, starting from very basic manual guidance with the Easy Guide 250, for example, starting only around about £1,200 at the moment. So it's really not that expensive technology, and the savings can be quite quick, really, in terms of your inputs, but also your time as well. So moving on, we're going into application control now. So the second element of what we do with GPS. This can be split up into two parts. The first being variable rate application, and the second being section control. So when we talk about application control, those are the two things. So, and it's basically boils down to putting your inputs, your sprays, your fertilizers, your manures in the right place, and that can have a lot of impact further down the line. So the first part of that is variable rate application. So essentially it's adjusting the application rate of an input according to field specific or very local specific conditions. So this is mainly used on spreaders, sprayers and drills. And you can get data from various sources. Again, as I mentioned, Ben, with Agri, we've been speaking about this yesterday, where you get this data from, so aerial imagery, I imagine, soil testing and this sort of thing, but also from yield data, so from previous year's yield data, and that can be in forage crops as well as cereal crops. So you can get yield data and then treat the field the following year according to previous results. So basically, we're applying the inputs where we need them, rather than just blanket applying across the whole field. Some people have got examples of how this can save money and save inputs, and in certain cases it will. Personally, I don't always go in with this saying you're going to save a lot of money or the inputs, because I prefer to look at it as putting it where it needs to be rather than blanket application. So you're treating the field in smaller zones. So rather than looking at a whole field, you're looking at smaller zones or compartments of that field and treating it more or less with the application. So you could end up putting on more, but you're actually treating it according to what it needs rather than just what you guessed, basically. And the benefits of that is that it's a more even crop across the whole field, which then helps you to maximize yields, and it makes it a big difference to harvesting. And again, it's like having stripes in your grass. It can make it a lot easier if the whole field is the same. It makes the job a lot easier. Coming back to cereals a little bit, I've had customers tell me that it's a lot easier to drive, or a lot easier on the combine harvester if they can keep a constant speed through the field, due to having planted corn and treated it with variable rate application. And then following on from that is the section control, and this is where the obvious savings come in. So we're essentially turning on and off an implement section by our GPS position. So the system knows where it's been and what part of the fields it's worked already or done already, treated already, and it will actually actively turn off all or a section of the machine based on that information, rather than guesswork of thinking, I think I've done this before, so I'll turn off. And again, obviously, this is for spreaders, sprayers, and seed drills. And the obvious thing is, reducing overlaps and misses. So you can save chemical here. You can see in the center picture. So this is turn off as he's coming into the part of the field he's worked already. So he would the operator would have gone on another quite a distance before that would normally have turned off, or before you would turned off, to ensure you get the whole field covered. In this case, it's turned off, so he saved quite a triangle. And we all know we're not farming in big, nice, open, square fields very often. So this is particularly useful in smaller fields. So actually, potentially, the smaller and the more awkward shape your fields are, you've got bigger benefits for the technology here. And this is really where you're going to get a potential input saving, and it makes life easier. It's another thing you don't have to do to check, and to keep an eye all the time to make sure you're not overlapping. And again, aesthetics, don't underestimate how important it is for stuff to look good. The maize crop at the bottom there, it doesn't look, it looks the part, doesn't it? We're not overlapping, but also then those individual plants will perform a lot better because the row spacing is maintained constant. And then the picture on the right-hand side, that can pretty much only, or almost certainly, have been done using GPS. So that's definitely for aesthetics. It's a maze somewhere. So how do we do this? The variable rate and section control. So we, as a GPS provider, we can actually connect to the machine. So we connect to the spreader, the sprayer, the drill through its own control box. Sometimes we do more than that. There's a lot of variations here. We can work with many different manufacturers, and there is multiple different combinations and different ways of doing this. So this is where the experience and the know-how of having done this for several years really comes into its own. And one of the ways we do that is over Isobus. There's a lot of buzz about Isobus in the machinery industry and around tractors and machinery. And people can often get a bit confused with it, but essentially Isobus it's just a standard. ISO is standard, and bus is a way of communicating. So it's a standard way of communicating with machines. So the way I like to look at it is we can have lots of different tractors and machines, and they all come from different places. They all speak in different languages, and that can be confusing and can cause confusion. So by the introduction of Isobus, we essentially put them on a common language. So we make them all speak the same language, and they can easily transmit information. And something important with Isobus is it's often associated with modern and new tractors or equipment. That's not always the case. We can actually, so we as Trimble then, or representing Trimble, can fit an Isobus to any tractor. Any tractor can be made Isobus. It's just cables at the end of the day to communicate. So we can put that on any tractor. So you could, sometimes get a good deal on an isobus machine, but be put off because you haven't got an isobus tractor. Well, actually, we can come along and put an isobus terminal and the cabling in so that it allows you to use that machine. And that can be something like application control, or just as a universal terminal to view the machine like a baler, and you just want to see the machine in the in the cab. So then moving on to the mapping and data management element of what we do. So again, we know where we are. So mapping, it's obvious we can map the fields, and then we're also getting a lot of data back from these systems. So the tractor is all the time, it's painting and showing you where it's been. It's also recording where it's been, so we can get that information off, download it via USB or over the air, and then we can see where it's been, and that brings with it some other benefits we'll look at in a second. The first one, mapping. So this is an example I've got from home. So the map on the left may be familiar, or the style of map, that's an RPA map. So we've drawn on that, or written on that, our field sizes, which were given to us, at calculated field sizes. So normally we go out and buy the inputs, the fertilizer, the chemicals, based on that size of that field. Actually, while I was doing an operation, so I was, I think, rolling the field, I mapped the field. It can do it at the same time. And I've actually mapped the physical growing area of the field, or the we call it the tillable area, the area we could work if we were ploughing it, for example, or mow or something like that. And the working area of the field is 5.5% less than what we were, or the total area of the field. Now, 5% might not seem much, but if somebody gave you the option of paying 5% less on your fertilizer bill, I'm sure you would take it. And that's basically what it is. Why, if we're testing the fields and we know we're putting the right amount per the soil conditions, why would you put more on for the size of the field than the field actually is? So simply, when buying all your inputs, buy on the right area. And I've had customers in an arable scenario who have got margins as well around their fields, and he's actually had a 10% reduction in his field size, which might not sound like a great thing. He saved enough in his first year buying less chemicals that he could pay for the GPS system in the first year. So there's some really big savings to be had there. And then the other side of it is the data management. So like I said, all the time we're using the systems, they're recording information, particularly when they're linked to a machine. So in this case, where the GPS system is linked to a fertilizer spreader. So it's actually recording as well all the time how much it's putting on. So in this case, that you can not only can we see like when we started and finished the job, how long it took us. So as a contractor, that's really valuable. We can charge really accurately and by the field size, by the actual field size. But we can also know exactly how much we should be putting on and how much went on. So in this case, we can see the maximum minimum rates where we were putting maybe a bit less on, we were going a bit faster or something like that, and exactly how much fertilizer went onto that field. And then we can check whether that's what we want and adjust accordingly for the next application. So this applies for bought-in fertilizers, but also things like manures. We can record that. We'll see shortly. And this recording of information is going to be more and more important. We know we're getting more and more demand for record keeping. So why would you want to go home at night and then have to write all that down, write how much you've put, written records, you get lost, it's difficult. This can be fully automatic. So we can get the data from a GPS system to the farm office with no USB keys, no paper, for as little as £300 a year. So it can just fully synchronize, and all your fields are saved and backed up, and all your data is fully recorded basically. And then we can use that then for crop assurance and different assurance schemes. You can just show them your record directly on the farm office computer, or on your mobile in your hand. It's a really easy solution. And an example of this is slurry recording. I know it's a hot topic in Wales at the moment, is slurry and manure application. So we've actually got a system that can record the exact amount of slurry, whether that's from a tanker or an umbilical system. So we can actually So the GPS system could be used as a guidance to steer the tractor to avoid any overlaps or misses. You can see from my picture I was missing quite a bit, but that was this is only a test. But then it can also give us an as-applied map, so we know exactly how much manure went where and when. So you've got full traceability, and again, this can all be automatic. So we can fit this to pretty much any existing system in the field. So you need a flow meter on it, we can put one of those on. Then we can fit an isobus system which can integrate with a GPS or a tractor, and then record your rate. And I think this is something that's going to become more and more important going forwards, if not mandatory. So hopefully that's given you some ideas of some of the stuff that we're involved in and that we're doing. It's a very quick and brief overview. I'm just going to show one last video just with a few more examples of what we're doing, and then we'll go into some questions. Cool. So yeah, thank you for your time and your attention tonight, and hopefully hand over back to Delana with some questions.
Thank you, Andrew. That was great overview. I'm still surprised at how many of the starter packs that units that you sell, the light bar ones, because we've run meetings with Ian Beecher-Jones, a precision farming consultant, 2 or 3 years ago, and he said accuracy is infectious, and as soon as people start on using GPS technology, the first kit they buy, they soon find that they wanted to get more accurate than what they're actually doing. But actually steering a tractor following the lights is still, you're selling a lot of them apparently, yes? Yeah,
we still do a lot of that, particularly in this part of the world. So we still do a lot of the Easy Guide 250s. They're really popular. It's simple, it's really easy to follow, it's easy to see where you've been, and avoid the overlaps that we don't want. But you can also use it on things like, like on a quad bike, which wouldn't suit a bigger, more complicated system for things like applying grass seeds or slug pellets or something like that. So we do a lot of that this time of year. And then moving on from the Easy Guide 250, we've also now got the GFX 350, which is a little bit more expensive, but not a big jump up. It's a 1850 with us. And the beauty of that, like you said, the accuracy can be very addictive. People often see once they've tried it, they want more, they want to add steering and they want to add accuracy. The beauty of the GFX 350 is that's fully expandable, so we can add to that. We can go right up to full accuracy with it. It can do all of the steering systems, and it can do things like the isobus recording of rate and all that sort of stuff as well.
Of course, it's not always the case that it's advantageous, because I can remember being told of a young farmer in Glamorgan who the mist was coming in, and he decided that he wanted to finish for the night to go out. And he said to his father, I can't do any more because the mist is coming in now. And his father said to him, you've got GPS technology on your tractor, you carry on.
Yeah, absolutely, yeah.
Not always advantageous. Anyway, we've got some questions coming in. First of all, someone says, I bought a Trimble 750 last year and used the small business grant. It's already helped with getting better application with fertilizer spreader as opposed to bout marker. The OCD in me makes me want to buy an easy steer, like just been said. Any advice on a simple vary spread fertilizer spreader I could buy to help better efficiency?
Yes, there's a couple of things in there. So yeah, the 750, perfectly acceptable to add an easy steer to it. And that's actually bizarrely for Technology, but that's come down in price. So yeah, that's a really good add-on, and it's good if you want to move it between a couple of vehicles. When it comes to fertilizer spreaders, it depends what you've got already. There might be something you like, but we as Trimble are compatible with most spreaders that can do it. So if you're looking to do some sort of vary spread, most manufacturers will have a solution for that, and we are compatible with most manufacturers. So it would come down to your personal preference. I don't want to pick out one particular manufacturer as being better than the others. They're all pretty good. The important thing is to when you're looking at it and when you're specking it is speak to somebody like ourselves, like Henry, who's got the experience and can say whether that will work with your 750. The 750 is really versatile and will work with a lot of different ones, but it's always good to check first.
Thank you. The next question, Andrew, can you discuss controlled traffic systems in silage making? Lots of machinery involved, maybe 4 to 5 trailers, etc. So expensive to have guidance on all tractors. Is it possible to have a system where all tractors talk together to cut down on the technology required?
Well, that's a good question, really good question. So controlled traffic farming might not be familiar to everybody, but that's essentially where we put all the vehicles run on the same path. So to avoid compaction across the field, we're running all a little bit like tram lines in an arable crop, but they're fixed potentially from year to year or at least within a season. So you don't drive off that. It's like a road almost. You don't drive off that road. And one of the key parts for controlled traffic is GPS, because it's really important to stay where you're supposed to be. It's very popular in the arable world, but it's not a big thing in grassland. I have seen experience of it in Denmark and Sweden. They do quite a bit of it, and so in forage applications, it's a challenge. It's quite exciting. It's an interesting challenge. The key then would be to have your rows not too far apart, because you're going to need to, you can go through with a triple mower. We've seen the video earlier with potentially a grouper on the back of that or a rake behind that. But you're going to need to either, then if you move through with the forage harvester, you're going to need, or the baler, the forage harvester first, you're going to need to transfer that to a trailer. So you're going to need to blow it, and we don't want to blow it too far. So the trailer needs to also be on the adjacent tramline or roadway, or directly behind. When it comes to vehicle shearing systems, that's, I think, where we're going to see the next step in this technology. So at the moment, a few years ago, having auto steer was quite exciting, whereas now that we see that's more and more common. What we are going to see more of is the follow me technology, where one tractor leads another. There's some projects ongoing with that. There's some concepts of that already. Where basically you have a lead tractor, in this case, for example, a forage harvester, and then your secondary tractor will basically pull alongside and be taken control of by the lead tractor. So they're linked as such. But we're still a little bit away from that in practice. But that's I think where we'll see the next gains in this GPS technology, really.
Right, the same person, Shreen, has also asked or added to that question, also distance between swath an issue, if too far, loss of forage. How can a forager system work best with CTS forage wagon is better, as no need to follow on the side.
Yeah, absolutely. So forage wagon is the easiest way to do it, and they're generally quite low ground pressure. Or like I say, a forage harvester with like swaths not too far apart. That's maybe not the most efficient way to go if your crops are light, but it's the only option. You've got to, the limit is how far you're going to be able to blow the grass or the forage. Or the other option is to tow the trailers behind the forage harvester directly behind, or blow it over the top. That's the other option. You can do, I've seen it with bales as well. So baling is an option. Picking the bale up is tricky. That's where some sort of bale chaser or something like that can actually push the bale to one side. The tractor stays on the track. The bale gets pushed to one side and then collected by a chaser device.
Thank you. Another question, how much more accurate is the more expensive system than the light bar? Yeah,
good. So the light bars, they all come with the free signal, which we call EGNOS, and that gets you to roughly 20 to 30 centimeters, which is fine for your broadacre spreading of fertilizers and spraying and this sort of thing. Then we go up in stages. So the next one after that is what we call Range Point RTX, which is an annual subscription, and that gets to 15 centimeters past the pass. So when we talk about accuracy, that's another important thing. It's understanding what it means. So it means to drive up the field and turn around, and you come back and you're within 15 centimeters in that case. Well, the next one after that is what we call Center Point RTX. So that's the equivalent of what used to be RTKs. This is where all the acronyms are coming in. But Center Point RTX is now satellite available, so it's available anywhere. You're not tied to a base station or a mobile phone. It's coming from a satellite, and that can get you down to less than sub-inch, so 2.5 centimeters, and that's repeatable. So for things like controlled traffic, it's important to be repeatable, where you can drive down the line and then come back the following day, week, year, and drive down the same line. So 2.5 centimeters repeatable accuracy.
Thank you. This webinar follows on from one we had last night on soil mapping. Our demo farm at Pantaderi has had soil mapping carried out on 100 hectares. Interesting what you were saying about saving inputs. We actually talked about it last night, but we managed to save £1,000 worth of lime by applying it with a contractor that could do it variable rate using the soil maps. But ARIG at Pantaderi wants to make an investment in tractor GPS. He's wondering whether he should change his tractor or have something fitted to his existing tractor. You're talking about a mainly grassland livestock farm, but they do have 60 hectares of arable. Obviously, there's several tractors on the farm, but what operations would benefit most, and what system would you put on if ARIG was to put a system on his existing tractor? Sure,
that's a really good question. So in terms of operations, the first part, in terms of operations, to be honest, all field operations benefit from using GPS. It's surprising. I struggle to think of a time where I wouldn't want to use it, really. I know myself, obviously an advocate, but I've started with it on grassland for fertilizer spreading, and then you soon think, well, actually it's really handy for rolling, for then harrowing or anything like that. Then mowing, obviously, I think we spoke earlier about an example where when you're mowing in a triangular field, you can make sure you're making the most out of it, so you're not getting so much short in the field, which then has a knock-on effect for all the other operations, the tedder, the rake, the forager or the baler or whatever. And so really it has a benefit across all the applications in just simple ability to drive parallel. Arable, again, it's the same sort of scenario. Sort of any sort of ground preparation, it's really beneficial. Drilling, it's obvious benefits of drilling, and then spraying and spreading as well, of course. In terms of which system is the best, it really depends on what tractors he's got. He might have a tractor which is already auto guide ready, so it's already partially prepared. which case I would suggest using that, and we can link into that. If the tractor is maybe something slightly older, is not auto-guide ready, probably the easiest starting point at the moment would be a GFX 750 with Easy Pilot Pro. That's a really versatile, so it's the electric steering wheel, a GFX screen, so that's capable of doing isobus, capable of all the accuracies, you know, should he need it. But it's also easily transferable. So if he then changed that tractor or changed his tractor to a bigger tractor, you could take that system and move it from one system to another. So you're not buying a new system every time you buy a tractor, which is sometimes a trap people can fall into when they're buying a factory fit, is you're paying for every time you buy the tractor, and it's got to go with the tractor, and you've got to buy a new one.
Mm-hmm. Thank you. It was really interesting what you were saying about data management, because I think we are, as you highlighted, we are going to be forced into keeping more accurate records, knowing exactly what has gone where. And this technology is really facilitates that, makes it easy, doesn't it? We were discussing last night that the variable line maps were passed on an SD card to the contractor, just plug it in, and then you can download what you've actually done onto your software program afterwards without having to even tell the tractor driver how much you want where. It's all on that card ready. I'm quite interested in your slurry, huge slurry, was it an umbilical system with all those jets on it. How many contractors in Wales, because presumably that's a contractor's machine that you could have in to do that? Is that right?
Yeah, so it's not mandatory at the moment, but I think it will end up being mandatory that we're recording, you know, exactly what's gone where, like proof of placement, very accurately. At which point it's that sort of equipment is going to be essential. There's a lot of people would be monitoring it at the moment. So a lot of systems would have the capability to monitor, so they can tell how much is going through the pipe. So that gives them an idea of what sort of rate they're putting on, and they can get an idea then at that point. But I don't think there's many at the moment who are fully recording it. It may be one or two that I know of that are really recording it and embracing it, but not that many at the moment. Obviously, knowing how much you're putting on is important for the rate, and you know how much you've got to go. But most people just want to get it on until their stores are empty, which is arguably not the best thing to be doing, is it? We need to be making sure we're putting the right amount in the right place to get the best benefit out of it. Then we need to start looking at, you guys are into it, looking at slurry as a resource rather than a waste product, isn't it?
And was that picture you showed, was it a machine in Wales?
The Massey Ferguson was a machine in Wales, yeah.
Mm. And how many contractors in Wales would have that kind of facility?
I think that's a good question. I don't actually know the answer, to be honest, but I would say probably most umbilical systems would have the capability of measuring, but they're probably not using it to the most they could at the moment. It probably could do with adding an element to measure what's gone where. They can measure, but they don't necessarily what has gone where GPS wise.
Mm-hmm. Another question has come in. Might be a silly question. Is the receiver always on the roof? We have lots of branches over tracks around the farm that hit orange beacons on roofs. Is the receiver movable or fixed on the roof?
Good question. Yeah, I know. Yeah, I often have a discussion about the amount of trees we have. To be honest, the roof is the best place for the receiver because it's the best place to get the signal. We're looking for satellites which are in the sky, so we want to get as close as possible, and that's the roof. You can put the receiver elsewhere. So in some cases, I've seen it put on the front of the bonnet, on the very nose of the bonnet. And it depends what you're doing. For automatic steering, the best performance is gained when the antenna is closer to the back axle. That's a technicality, but if your manual guidance, actually the best performance is when the antenna is further forward. So there is an argument to put it on the bonnet of the tractor. Yeah, it depends. I'm not sure exactly what this guy is doing, but there's no reason. The only reason not to put it on the bonnet would be for worrying about shading of the cab, so it's causing a shadow essentially.
Thank you. If there are any more questions, please type them in now, or it'll be too late. So anyway, I would like to say a big thank you to Andrew for running through those options. I think there's a lot of farmers out there that would like to dip a toe in the water, but they perceive it as being sort of technology that maybe they don't understand that well, and it's expensive technology, and any guidance and advice on what suits their situation is very welcome. So thank you very much to Andrew. I think Ben has come back again and says, so are the receivers fixed permanently or movable?
So ours are generally on magnets. So they have a very strong magnet on the roof, and that has two benefits. So if you do hit a branch, usually the receiver will just fall off, and it's cabled on. In the worst case scenario, you break a cable or something. But so you can. This is another advantage of having a retrofit. If you have a factory fitted solution, it's usually bolted or fixed to the cab. So a retrofit with ours, they're usually magnet. Sometimes we bolt them down because it's important that receiver is in the same place, particularly when you're doing auto steering. We're talking about very high precision down to centimeters. If that antenna moves, that's our reference point and the tractor will move. So it's important it stays in the same place. So all of ours have a magnetic base as a minimum. So providing you've got a metal base to put it on somewhere on the tractor, that's good. I don't want to be careful not to advise people. Some people talk about putting the antenna on the implement to get better performance. I wouldn't advise that. It needs to be around the back axle, if not forward of the back axle.
That makes sense. Thank you. Right. Just to remind you again that Henry Gibbon is available through the mentoring service. You won't be bound to buy anything off him if you have him through the mentoring service. You'll just be providing advice. So please make use of that because it is funded. Oh, we've got another question. How much would it cost to put an auto steer on a tractor? Yeah, and that's from our demo farmer.
Good question. So we have our sort of simple systems. Auto steer simple would be starting around about 5,000. The system I mentioned with the Easy Pilot Pro with running on a range point accuracy is going to be around about it depends on the tractor, but around about the £8,000 mark, and that's installed pricing.
Eric's going to go to his tractor dealership now and say how much to have a factory fitted one and see what the difference is it? Great. Or maybe you'd like to subsidise him as a demo farmer.
You never know.
That would work well. All right. So thank you very much, Andrew. Really beneficial and useful. So diolch I chi gyd am ymuno yn ei heno. A allai ddweud wrthych chi os erfyn arnoch I lanw'r daflen werthuso ar fel bod chi'n gadael y webinar os gwelwch yn dda. Thank you very much to you all for joining us this evening and all your questions.